algebra. Right. So before there was a SQL and structured query language and relational databases and any of that, right? There was an entire theoretical foundation, right, around data storage, data retrieval, and it was mostly based on set theory, right? Based on being able to say, well, if any data point belongs to some set of a cloud of data points that belongs to the same set, right? That presumably they all have the same fields, the same data types, and whatnot. Yes, and so our tables are going to behave. We're going to treat them as if they were indeed a set, yes, of data points in that set. Yes, and why do we have many sets? Well, because we went through multiple normalizations, right? We started with one big table, and we decided to split it up into two, then three, then four, right? And we normalized the table. We normalized our database, right? Eliminating this redundancy. But whenever we want to query something and we want to know about something about a faculty or a course, we'll realize that the data is not always in one single place, right? Some of the information ended up in one table and some of the information ended up in some other table. Yes? But we need to now reconstruct the original data, right? If we want to know about something about the employee, we'll need to say, well, some of the information about their personal information is in this table, but about their address or phone numbers are in these other two tables over here, and the projects that the employee is working on is in some other table, right? And if you want to ask anything about giving them a raise or whatever, you're going to have to go and fetch information that is stored and spread out over multiple tables, right? Records across many tables. Yes. So we need operations that allow us to somehow relate all these data points, right, related to some other data points, right? And the operations are based on set theory, being able to do ands and ors and unions, right? And that amongst all these data sets, find me all the employees that worked overtime on these projects that had the most income, right? And had the reviews were stellar from their customers. So well, all this information is like everywhere, right? And you're doing all these ands and ors and nots, yes, amongst many of these data sets, and you need to join them together, right, to come up with an answer, right? So that's set theory. Anyway, so there's a lot of algebra and mathematical theory behind how to interact with these data sets. Yes, and this is true for any industry, right? Before there were any computers, a lot of folks were coming up with lots and lots of mathematical theory behind it. Lambda theory and all these operations and the Turing machines, right? These people had invented computation much before any computers were able to be built, right? So same thing with databases. A lot of theory came before we thought of building the first database. So folks were looking and said, well, if we have these data sets with these data points, what are the operations that we can operate on, right, on these data sets, right? So one of the operations was the select operation, meaning I have a data set. I like to be able to select certain data points in that set that meet a certain criteria, right? Meaning I have to be able to give you a criteria, some predicate, right? And I will only want the data points in that data set, only the data points that meet a certain criteria. So that was the select operation. Then there's project, right? Where I might tell you that that data point that I want is going to have a whole bunch of fields, right? And we'll have an employee might have first name, last name, username, password, salary, the date they were hired. They might have like 20 different fields. I would like to be able to tell you which of those 20 fields do I actually want. Do I want all of them, or I just want 3 of them? Yes. So project allows us to do that. Allows us to be able to tell which fields do we want. We have sort. Usually when you think about set theory, the data set and the data points in a set are not ordered in any particular way. There is no first data point, second data point, third data point. Yes, right. The order does not matter in set, but it does matter to us as human beings, right? If we're searching through a phone book, ideally, we would like to search it by last name. Yes? And so we invent the sorting mechanism where we sort things using binary search, whatever, keyed off of the last name. Obviously, that sorting mechanism means nothing if I want to search it using the phone number, right? And then no, I would like to sort it by phone, right? So I can search binary search using phone. Yes. So sort is only a convenience for us humans, right? How do we want to retrieve the data and consume that data? It's nothing. It's nothing that is inherently that is inherent about the data itself, right? The set itself, it doesn't will never have an actual order, right? It's only a sorting, only for our particular convenience and how we want to consume the data in a particular at a particular time. Make sense? So yeah, so data is always will be unsorted. There's also rename where you might want to change the name of a field. You might want to change the name of a data point of a data set, right? And we'll see how important that is when you, especially if you have data points that you want to relate to data points in the same data set, right? Where you might want to create hierarchical data structures where you might have employees and that report to some other to some other employee, and that employee might report to some other employee all the way up to the CEO. Yes. So to be able to manipulate or do operations on data points that are related to themselves, right? Renaming is very important. We'll see how that's important. Extend is it might be that to avoid redundancy, we might not store certain things in our data set to avoid redundancy. Things that could be calculated on the fly. For instance, I might not want to store in the database. For instance, I might have first name, I might have last name, middle initial. Would it make sense to also store full name as a field? Probably not, right? Because it would be redundant, right? There would be a dependency, right? Because full name depends on three fields, on the first, the last, and the middle initial, right? So full name might be a field that I do not store in the data set because I'll always calculate it on the fly from the other fields. Make sense, right? Or I might calculate your weekly salary from your hourly salary. It would make no sense for me to store both. Well, unless I can always calculate with how many hours you worked that week and your hourly salary. I can always calculate how much you made this week. It would make no sense for me to store all those three things in the same data point. Make sense? So some fields are certainly not meant to be stored. They're meant to be calculated on the fly. So you would use extend. Extend allows us to calculate things on the fly, new fields. Group by also allows us to do operations that might relate records that are related to one another based on the value of a particular field. Maybe we all belong. We all have we all belong to the same club. We all like Mac OS, or we might all like Volkswagen, or we might like whatever field that somehow relate us, right? And we might want to be grouped in a particular, using some value of some field, right? So group by allows us to do that. It also allows us to encapsulate or collapse or do calculations about the group. Maybe want to say, well, how many here have Mac OS and how many have Windows? Well, then I can group you by Windows and I can group you by Mac OS, right? And then I can count how many there are. That's a very simple one, right? Or I might do a group you by quizzes, right? And then calculate the average on a particular quiz. Yes. So group by allows us to be able to answer questions by grouping certain records. Product allows us to start looking at the different possible combinations that we might be in, right? As in being able to look at all these records that might be related to some other records over here, right? Usually when you search through data, so not only are we storing data, we are always also interested in retrieving the data, and we know that data might have been split across multiple data sets. Yes. So if the data that we're looking for is only in one data set, well, the typically what we would do is iterate over that data set, looking for the records that might meet a criteria. That's select. Right? Select says, give me a criteria. I will loop through that data set looking for the records that meet that criteria. Make sense? Right? But if I have a data set here and some other data set here, and somehow this data set is related to that data set, what would we do? You know, say I have to iterate and say, well, give me all the students in a particular department, right? Well, I have the departments over here, I have the students over here, and the students have references to the department. So I said, well, give me all the students in the computer science department, right? Well, now I have to look at the at this data set, and as I look at the student, I have to iterate until I have to loop through the other one also, see which one matches both the student and the department. Yes, and when they both match, it says, ooh, it matched, right? I'm gonna grab that student, and then I go on to the next student. You know, I'm looking, iterating, looking until it matches the computer science. When I find it, oh yes, computer science, I'll take that one. Yes, no, yes, 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 no, no. For each one of them, I'm looping like an inner loop instead of another, right? It's like a nested loop. Make sense? So in the worst case scenario, I have to loop through the entire set of students, and for all iterating for each student, I have to iterate over the entire data set in the department. Yes. So now I have two nested loops. That's what in order of magnitude. What is it? It's n squared, right? If say I have now, what if I have to iterate over 3 tables or 3 data sets? That's n cubed. Yes. So worst case scenario, it is the product of the sizes of each one of the size of. So if one table is size n and another table is size m, then worst case scenario, it's n times m. It's the product of having to iterate over all of them. So product allows us to consider all the possible combinations between all the data points in 2, 3, 4, 5 different data sets that are somehow related to one another. Yes. Then join is a combination of both. The product allows us to say, well, here are all the possible combinations, and then you come and say, well, I don't really care about all the combinations. I'm looking for certain subsets of all those possible combinations. You know, some combinations might make sense, some combinations might not make sense, right? So, for instance, if it depends on the question you're asking. If you're asking, well, give me all the students that are in a particular department. Well, I only care about those possibilities where the student, right, has the foreign key of the department is equal to the department on the other side, right? If they're not the same, then I don't really care about those, right? So joins allow us to do a subset of all possible combinations, right? The product the product considers all possible combinations. Joins allows you to filter them. Semi-join is a different version of join, where join, you're looking for data sets, data points are that are, you know, some fields that are in one of the data sets, and some fields that are in another data set, right? You know, I want to know this student and the courses that they took, right? Because I'm building their registrars. So for the registrars of it needs to create a report. Well, I need to iterate over students. I need to iterate over the courses that they took and build a report. You know, some fields from here, some fields from over there. And that's a join. That's a join. Sometimes I only really care whether there's a relationship or not. I don't really care about the fields on this other data set. I just want to know that there's a relationship. I'm not looking for fields. I only want to know that there is a relationship, right? And so semi-joins allow you to do that. It says, is there a relationship? There is? Okay, I only want fields from one of the data sets, not all of them. So that's a semi-join. We'll take a look at that in a little bit. Anti-join, sometimes you want the fields, the records that don't match the criteria, right? Meaning, oftentimes you care about the ones that meet the criteria. Sometimes you want to know the ones that don't meet the criteria. Or union, outer join. All right, we'll look at each one of them.